Hi, this is the podcast on multiple alleles, another non-Mendelian genetic example that Mendel did see. But in some traits, I'm just going to read from the top here, so just follow along. But some traits are controlled by more than two alleles. There's more than just one dominant allele, and uh, even when there are more than two alleles for a trait, an individual can only carry two alleles because you, again, have only two homologous chromosomes. Blood groups have three alleles that control trait for blood type, right? So you have the A gene. I'm going to just circle this. You have the A gene, you have the B gene, and then you have little I, which is O. Okay, because in blood types, and you can go to the chart here. You have type A blood, you have type B blood, you have a combination of A and B, and then you have O. And so what we see here is that A and B, right? A and B, these are all dominant to O. O is recessive. Okay, so the only way to get O blood is if both your letter combinations are recessive. All right, again, A and B are dominant to O. So looking at the blood types here, if you are A, if you are type A blood, you are homozygous for A. All right, you are IAIA. If you are heterozygous, it just means that you are a carrier for O blood and you pass that on. So if you are a type A person, you can actually receive, right? You can receive, I'm just going to put a little column here, right? You can receive type A and you can receive type O. Okay? If you are a type B blood, right, you're either homozygous, BB, or you are heterozygous, which means, again, you're a carrier. So if you have B blood, you can receive from B people, and you can receive blood from O people. Right, I'm going to make another column here that says, who can you donate to? Right, who are you a donator? So if you are type A blood, you can donate to A people. Right? That's it, because the thing is, if you donate to O people, they won't be able to accept it. What are we talking about here? We're actually talking about a protein on your cell membranes. Right? There's a little protein that identifies you as A blood or B blood, or if you're O blood, you just don't have it. Okay, so if you are A blood, you have the A protein, and you're someone that has O blood, their body isn't going to recognize that A protein and it's going to reject the blood. So really, if you're type A blood, you can only donate to type B people. Similar situation with B people. If you're a B person, although you can receive blood from B and O people, you can only donate to B people, right? And I'm going to backtrack a little bit um, when we get to type A people. Right? Because again, the reason why you can receive blood from other people is your body actually will be okay with not having the protein. But if it sees that, let's say you have B blood and you donate to O people, giving someone that B protein, their body won't recognize it, so they will reject it. Okay? The next blood type is when you're a mixture of both. Okay, so if you are AB blood, which is this is the rarest type of blood, you can receive blood from A people, right? Because you're the A gene, your body recognizes it. You can receive blood from B people because your body has the B gene. You can receive blood from, of course, AB people because, well, that's just who you are, and you can accept blood from O people. So that means that if you're type AB blood, you are the universal receiver. You can receive blood from anybody, but you can only donate to AB people because if you're AB and you donate to A people, then the body won't recognize the B gene. And vice versa. If you donate to B people, then the body won't recognize the A gene. And of course, if you donate to O people, they're not going to recognize any of the A or B proteins. So that'll not be good. If you are type A people, okay, you can donate to type AB people as well. And if you're B, you can also donate to type AB people, right? Because the body will recognize that A or B protein. So last but not least, again, before I start that, AB, you are the universal receiver. You can receive blood from anybody. Type O people, you can receive blood from only O. Everything else, that protein, not good. But you can donate to everything. So that means you are the universal donor because you can donate to everyone. You will receive blood. Um, And why is all this information? Why is all this information important? Well, it helps us. It helps us when we do blood transfusions. It helps us when we look at blood diseases. It helps us identify parents, right? Because sometimes, yeah, mistakes happen and babies do get switched at birth. So let's take a look at two examples here. Okay, two examples, and that'll be it. So a father has type O blood, and the mother is type O. You want to look at the percentages of what's going to happen. So the father is type O, looking at our chart, right? Type O blood, he can donate either an I or an I, and the mother is type O too. So it looks like all of them. 0% A, 0% B, 0% AB, 100% of the blood. Right? Let's go to something just a little more difficult. All right, the father is type A, homozygous. So looking at her chart, right, they're homozygous, so both his A's have to be the same. IA, IA. The mother is type B, homozygous. IB, IB. So what you get in the middle here, one donates an A, one donates a B. One donates an A and a B. You're going to get an individual that has 0% A blood, 0% B blood, 100% AB, and 0% O. Okay, let's do one more example, and then we'll wrap this up. So the next example is going to be just a little more difficult. So the father is type A, heterozygous. Again, heterozygous means that they're IA and little I. All right, their letters are different. If you're A, you just have the opportunity to pass that through gene. The mother is also type B, heterozygous. So they have a B gene, but their second letter is a little I, making them different. So in the middle here, we have an A and a B. We have a B and an I. We have an A and an I. And we have a little I, little I. So here we're going to see a scenario where we have all the blood, right? 25% is going to be A. 25% is going to be B. 25% will be B. And 25% will be A. So if these two individuals have children, this means that there's a 25% chance of any kind of blood. Okay? This concludes the podcast on blood types. Please see Mr. Matthews with any questions.